Hello class, in this video I'll be showing you how to find the intervals in which a function is increasing, decreasing, or constant. Let's begin. We will start with a little test, and it says, suppose a function f has a derivative at each point in an open interval ab. Then, if the derivative is positive for each x in the interval, then f is increasing from left to right. If the derivative is negative for each x in the interval, then f is decreasing from left to right. If the derivative is equal to 0 for each x in the interval, then f is constant, meaning the function is neither increasing or decreasing. Next, we have critical numbers, and the critical number for a function f are those numbers c, and I want to highlight the next part, in the domain of f for which the following are true. The derivative at c is equal to 0, or the derivative at c does not exist. And as you're doing these problems, always check the domain of a function before finding the critical numbers. And you'll see why as I do a couple of examples. Okay? Next are critical points. And the critical points of a function are the coordinates c comma f of c, where c is the critical number of f. So what I've done is I've gone ahead and drawn a couple of pictures to describe what is going on in these explanations over here. So in the first diagram, notice that the function starts by increasing. So here is where the derivative is positive. At this point in red, the function is constant. So c is a critical number, and f of c is equal to 0. After the critical number, the function begins to decrease. So in this small interval here, the derivative is less than 0. And I'm just going to include the endpoints here, a and b. Okay, over here to the right, I have another diagram. Just going to label the endpoints real quick. Notice the function starts and it's decreasing. So in this little interval here, the derivative is less than 0. At that point right here in blue, this tangent line is vertical. And since the tangent line is vertical through this point right here in red, the derivative at c does not exist. Remember that the derivative of a function measures the slope of the function at a certain point x, and since the slope of a vertical line is undefined, the derivative at that point will also be undefined. And after the critical point, your function is still decreasing, so the derivative is less than 0.